Right, as introduced, I'm Nino Vidovic. I work at Zegger as a software engineer, and the idea of this talk is to talk about exactly this question: debugging, why I write flawless code, and we will find out why. So about the talk content, I will first talk about the definition of a computer programmer, just to get into this topic. We will find out who are these people who write flawless code. We will learn why we should care about debugging anyhow, what are typical embedded debugging setups, and what is the general cost of these. And then we'll talk about debug features, and we have a little conclusion for this. All right, so when I got into this topic, I just typed in programmer into Google. I ended up at Wikipedia. This was the first paragraph. And I want to focus on this last sentence, that this is a person who creates computer software. What I was missing in this statement was that there's no talk about the quality of software here. And I was thinking, okay, it's software. Does it work? What kind of software is this? And as I'm a positive guy, I thought, okay, let's put a positive twist on this, and let's assume that all programmers are writing perfect software, right? So this led me to the following question. So who writes flawless code? So this is a question actually for the audience. So I know I do, so don't be shy, yeah? So flawless code happens sometimes. Yeah, but even if you're like a person like me who always writes perfect and flawless code, why should you still care about the debugging and having such a setup? Well, first and foremost, even if you say, okay, I know my stuff is working, maybe sometimes my colleagues screw up, but I know my repository is always clean and everything is great. You can still use this to have the validate your code. Yeah, you can prove your management or quality assurance that your code is doing what you say it does. You have control over your target. So say you're debugging some kind of motor system which has moving parts, weighs 3 tons, and if it keeps going and you can't stop it, it will crush you. This is something you don't want. That's why having control over your system is a great idea. Of course, you get easier code maintenance and testing capabilities, which your future you will thank you for if you move to another project, maybe another hardware, you have to port stuff, or you expand your existing code base, having a debug system, a setup that is working, that you know that was working at some point, is a big plus and saves time. And in general, you get powerful analysis tools. You can have deep insight in your application. You can optimize code. So even if you say, okay, I'm a person, I write always flawless code, it always compiles first time, it's great. It doesn't mean that you write efficient code. And especially on embedded targets, and the lower the specs of the embedded target is, say, low power applications, you don't want to waste CPU cycles for nothing. And yeah, this is where these analysis tools can come in handy. And all points together, well, they avoid follow-up costs. And maybe to tell a little story here on the follow-up costs that we had once with a customer, they called us in and said, hey, we have a problem. Yeah, we have a product that's ready to launch. We have a release build, everything's cool, but nothing's working. And we're like, yeah, that's bad. Okay, let's take a look. Can you turn on your debug setup? And they're like, no, you don't understand. We have a release build. We're like, yeah, no. Then click on debug and then debug it. No, it's not that simple. I'm like, why not? We don't have a working debug setup. I'm like, how did you ever come to the release? But different story. And what they did is essentially they put printf everywhere and hoped to find their multi-threaded bug there. It didn't work. So they spent, I think, 2 months to get their debug setup up and running, and then they called us again and said, hey, we have the debug setup running. We found the fix now in 1 day, thank you. And we were like, yeah, this could have been avoided. So just a little example from the real world. why it makes sense to still have a debug system setup, even if you have a flawless programmer team. So how does such a typical setup look like? So here's a picture showing such a general setup. You have some kind of MCU, DSP, some kind of CPU that has some kind of logic. You can program it, debug it. You have some interface between a probe and the target system, and usually it's JTAG. But there are also some others depending on what architecture you're on. And you connect this to some kind of host PC, usually USB. There are also sometimes other protocols, UART, but let's assume USB. And then you have your host PC, your laptop, some kind of computer that can interface with this probe and extract this debug data from your targets. Now, for all of you that are still stuck in the idea that such a debug setup is something enormously huge, like in the 80s or something, where you had a computer that was like this, where, I don't know, your debug probe was like this table and your board was the floor. That's no longer the case. I have an example here. So this is a demonstrator that I use. This is our trace probe. This is our largest probe. So everything with less logic is smaller than this, and this is some target board to demonstrate some features. This is of course a very small board, but the idea is to show you, okay, most debug setups fit on this square here. So we've gotten much smaller thanks to embedded systems. Yeah, let's talk about price. Oftentimes I hear, oh yeah, I would like to use all these tools, but they're for sure expensive and stuff. And I have to say, it depends. It depends what you want to do. Depends what features you need and where your project is going to. So I have 4 price brackets. The price lines are not really that cut as shown here, but it's just to give a number so you can work with a budget here. So if you're a private educational user, you're using, I don't know, an IDE Eclipse, for example, which you can use for free. You have some probe. For example, here's a J-Link Edu Mini, which can be used for educational purposes for 15 euros. You have your JTAG and SVD pin on the one side, USB on the other. That's all you need. You have, assuming, of course, with all these prices, that you have some kind of laptop at home. Let's say 20 people have this, I don't know. But this all prices include everything. So from the target board, the debug software you're using, and the debug probes. And yeah, this is where we're getting at. So if you're looking at the basic commercial level, entry level, where essentially you take the same setup you had in your private or educational setup, and you get a probe, which can be used for educational purposes, where you also get the benefit that with these probes, you're also getting support, commercial support from engineers like me, which is why, of course, the prices are a bit higher, but it usually comes with a nice premium that you can ask me questions and not bother some forum and hope that people answer. Then we come to the advanced commercial area. This would be like this JTrace here, where you get advanced debug features like hardware tracing, high-speed debug interfaces to 100 megahertz, and I don't know, stuff like that. You know, this is usually something that not many people need, but if you need it, you're happy that you got it. Stefan told me, for example, that recently they exactly used this model to debug some problem that they couldn't track down in another way, and yeah, then you're very happy to have it at your workplace set up, ready to go. Yeah, and then we have the last price bracket, which is like specialized setups, which would be something like super restricted NDA secret target CPU that nobody knows about, and there are only 5 setups of these on this planet. And yeah, we mostly focus on the first 3 parts with our products. There's sometimes stuff we do in this last one, but it usually is a lot of support to get something like this up and running. So yeah, as you can see, there's the typical cost for these setups, I mean, everybody can afford it. And I remember as a student, I was also thinking like, oh, getting such professional tools is a problem. I found out that it's not really the case. And I was happy with my limited budget back then. Yeah, and as we learned from the story I told with the 2 months debug setup search, such searches are always more expensive than just getting something like this from the beginning of your project. So yeah, let's get to like general debug features that you will usually find in most IDE or the debug software that you can get also as an open source program, for example. I will use the example here on Embedded Studio, which is our IDE. Here are the features listed that you usually can find and stuff like this. I will highlight it now so you get a better overview how this looks like. So you can of course set the breakpoints, so your code runs to the breakpoint stops. You can control it, you can set watch points, stuff like this, so you can control the program flow better. You got a printing terminal for I/O interfacing with your target device. You can control the CPU registers directly and even the peripherals, so you don't have to do this out of your application. If you want to toggle a GPIO quick, so you just go to the window, click it, and you know if it's working or not without rewriting your code every time. You can of course single step and step into in disassembly or in your C and C++ code. You have direct memory access on your flash, on your RAM, whatever the target has. And of course, you have the reference always to your C code or C++ code with the current program counter that is currently running. And we have a call stack. Call stacks are great if they work, and they mostly do. Now let's talk about advanced debug features, in this case with our debug software Ozone, which also can be used for free, by the way, and works with all toolchains, and it's multi-platform, so it doesn't matter if you have Linux or Windows or macOS. It simply works. These are features that you would get, for example, with such a JTrace Pro. And then again, highlighting, you have the code coverage from the instruction trace data that you get from the target, which is non-intrusive, so you're not changing the real-time behavior of your application. Here's again the instruction trace information from the beginning, from the reset handler of your application up to wherever you stop now, like a little time machine essentially. This can then be displayed in a timeline, so we grab all this information that we get from the target. You have a timeline. It's cycle accurate with your CPU cycles, and you also have a power profiling there, so you can measure how much current is your application drawing at the time where it's doing some task switches or turning on and off LEDs. And you can track variables with a certain sampling rate. And we got RTOS awareness. The window is a little bit small here, but you can of course resize everything. And here you get stack information and task ID information, what your tasks are doing if you're using an RTOS. And last but not least, from the advanced debug features, what I will also hold another lightning talk about on Saturday, I believe, will be about System View, which is our GUI to display code instrumentation. So you instrument your code, you write all these event handlers, and then you can have the real-time analysis of your system without needing really fancy hardware, but you can use any JLink debug probe essentially, and then stream this to your host PC and see while the target is running what your application is doing, where it's spending time, what could be improved. So yeah. So the conclusion, we saw flawless coders exist, yeah, but even I do profit from such debug setups. They save time and cost, and we have full control and insight of your target system. Of course, the more sophisticated the tools that you're working with are, the more insight you get. It can help you identify insufficient code parts, and as we saw, it's affordable essentially for any price bracket. And with all these price brackets, you can achieve a lot. So you don't have to have the high-end stuff to write good code. So yeah, before I finish this talk, I just want to remind you that I have also additional talks that will continue this debug information and this debug topic. On Friday I will talk about real-time transfer, RTT, the better printf, and more. So if you liked printf, you will love RTT. And I will talk about instrumenting an RTOS with system view. So if this is something you're working on or planning to do, I will show you how such an RTOS can be instrumented, that this is not really a complicated task, and you will get much more out of your target system when analyzing it. All right, thank you.